Okay. So next question is from page 1, stoichiometry redox reaction, which is 29. How many ml of 0.05 molar KMnO4 solution are required to oxidize 2 gram of FeSO4? So FeSO4 molecular weight is 152. Then KMnO4 also, we don't need KMnO4, I think so. We write the first reaction, so obviously. So KMnO4 is MnO4, minus will convert into Mn plus 2. So MnO4 minus means it is converting from plus 7 Mn to plus 2, means gain of 5 electrons happened. And talk about iron. Iron Fe plus 3 to Fe plus 2, or Fe plus 2 to plus 3 plus 2, because we will be there. So this will be again loss of 1 electron, because I am telling gain of 5 because we know the valency factor will be 5 in this case of NO4 and will be valency factor will be 1 in case of iron. Chalo, moving towards this reaction, because the neutralization, so number of equivalents will be same. Calculating the number of equivalents of KMnO4 0.0. We know as the normality is 0.05 into valence, molarity into valency factor is 5, will be normality, and number of equivalents will be normality into volume, that is V I am taking. So this is the equivalent, milli-equivalent of KMnO4. Yes or no? So we can write 5 by 25, 0.25 into V will be the milli-equivalent, will be equal to milli-equivalents of iron. So milli-equivalents of iron will be given mass, it is 2 gram, molecular mass is 152. And as we know, valency factor is 1 only, so you can multiply 1 or yes only, it's up to you. Then to convert it to milli-equivalents, multiply by the 1000. Calculate the value of V from this equation. So it will V equals to 2000 upon 152 into 0.25. Dividing or multiplying 152 into 0.25. 152 into 0.152 multiplied by 0.25, it will equals to 38. So 2000 divided by 38 will be the volume. So 2000 divided by 38 is how much? 2000 divided by 38. 2000 divided by 38. 2000 divided by 38. We can get the exact value from the calculator, that is 52.63. 52.63. Exact value is 52.63 ml. So 52.60, if I say C option is 52.63 ml. Okay. Thank you.